So simple attacks, as you can probably imagine, well, they're pretty straightforward. You just pick a system, you pick a port that's open that you believe you can get connections on, and you just start sending traffic. If you want some help, you probably do. You want to actually find or infect folks. You want to find peers, other hackers. You want to remote into systems and conduct the attack that way, or you want to infect zombies and get a lot of help that way, whatever. You can actually scale the attack up and out, but it's at its core, it's a pretty straightforward and simple type of attack. It's just, do you have enough scale to overwhelm the target system? That's really the limitation. So for example, a simple denial of service attack, just a single attacker, single defender, is really about finding a service that you can target, something with open ports, something hopefully with some vulnerabilities, but certainly a server or service that will accept incoming connections. And these are some typical ones. Email servers, DNS servers, web servers, very typical. They almost always accept incoming connections. Oftentimes they accept unauthenticated connections, and then authentication is performed later. FTP servers, telnet servers, all that kind of stuff. And then overwhelming those services. So finding a service that accepts more than one connection and maybe doesn't have a limit on the maximum number of connections, great. The best way to find out it doesn't have a limit, an upper boundary on the number of connections, send it a few 100,000 and see what happens. And then send specific queries or data or information to those services. So for example, in these cases, don't just request a web page, don't just slap F5 a bunch of times, but actually, if it's a web server that has a search engine, request a complex search query, request something that's going to take some horsepower to resolve. Doing that just once may have a noticeable impact on the back end. Doing that 100 times a second will probably bring that server down. Resolving DNS queries against DNS servers, same kind of thing. Resolve especially complex queries that are not cached, not typical queries. Do that enough, it'll bring that service down. And lots of email attachments, large size email attachments. If you can get a legitimate account on it, that's great. If you can't, that's probably fine too, because it's pretty easy to spoof that kind of stuff. And those are service-based simple denial of service attacks that you can actually mount almost universally against these types of servers. You just need to find servers that are configured in a way that allow you to do this. And as I note down here at the bottom, if you're not targeting specific services, you're really just sending a bunch of traffic to the host, to the switch, or to the server, and that still can work. It just may be a little more complicated. It's not quite as elegant, and certainly requires a bit more traffic. So now I'm going to go ahead and show you what a simple denial of service attack looks like in our environment here that I've got set up just for attacks. So remember that we've actually done the network footprinting and scanning and enumeration processes already. So we've got a pretty good idea of what's going on the network. Typically I use a paper notebook and I screen cam a lot of it and take a lot of screenshots. In this particular case, I'm going to show you this window that I showed you in a different video, the advanced port scanner. And as you recall from that video, we found a bunch of different systems on the network out there, including this one, 1.16, which wound up being a domain controller, a Windows Server 2008 domain controller, as well as a web server and a couple of other things. Had a few different interesting items on it. Well, if it's all of those things, I know that I can possibly mount a denial of service attack against it if I want to shut down authentication process, if I want to shut down network change, all that kind of stuff. So this will be the one that I select for the moment based on what my intentions are for a denial of service attack. So I'm going to come over here and I'm actually going to launch my favorite tool for attacking systems like this. It's called the Low Orbit Ion Cannon, or LOIC. I'm going to run it as admin to make sure it's got no problems with compatibility. And I'm going to go ahead and tell it to attack that server, the server that I specified just a moment ago, 192.168.1.16. I'm going to lock onto it, make sure I know what server I'm attacking. I'm going to choose a port that I know is open. So typically I can choose port 80 for web-based attack. I can really choose any port that'll accept incoming connections, which is kind of nice. And I'll choose TCP to actually start tying up a bunch of resources. You saw that just a moment ago. And let's go ahead and mount the attack. And you can actually see the requested going up and up and up and up and up. And depending on how long we're waiting, depending on what's going on, this may or may not affect the performance directly, just one client attacking this way. But this denial of service attack doesn't just have to stop with one client. In fact, in a typical denial of service attack, I will actually mount this attack against different ports at different times and try to footprint, am I affecting services? Am I starting to shut the server down or impact it in a noticeable way? Or I'll scale this out by running the low orbit ion cannon on a dozen machines or 24 machines or 100 machines at the same time. A lot of this can be scripted. I can actually capture the traffic here and replay it at the command line on different targets, or replay it as part of a script on different attackers. So some of my zombies or some of my peers can attack at the same time. This is the easiest tool to understand what it's doing because it's pretty darn obvious what it's doing. And it will start to slow down a little bit, partially because I'm consuming resources on the client, but also because the server itself is either getting slower, consuming more resources, or it's actually starting to defend against this type of attack. It's recognizing the pattern. Recall that the pattern itself has some specificity to it that some hosts can identify. So we may come down here, or I may come down here and change it to port 88, because I know from this window, from Advanced Port Scanner, that port 88 is also open. So I'll go ahead and switch over to port 88. And maybe I'll slow it down a little bit to confuse the pattern on the target. And there we go. And now we're attacking a different port, which is going to be a different service in a slightly different way and with a different speed. Speed is only really important if I'm attacking from one source. If I've got 100 people attacking, I can slow it down from each individual source and still mount quite an effective attack. That is what an attack looks like when we're doing this kind of denial of service. The only thing I want you to be cognizant of here is that I'm only showing it to you on one machine. It would look the same if I was attacking from 100 machines or 1,000 machines. I would just need the low orbit ion cannon here to be running on a bunch of different systems at the same time. That's the big difference. Wasn't that fun? So a distributed denial of service attack, just imagine that same attack, but many, many, many people doing the exact same thing at the exact same time. That's all a distributed denial of service attack is. It's complex because of the scale, but the actual attack itself is exactly what you just saw, just a lot of people at the same time. The trick really is just getting everyone to launch it at the same time, which is why you use malware, because the malware can be timed, it can be controlled, and it can implement all of that attack at exactly the same moment. That's why you don't just telnet into a bunch of machines one by one and start an attack, or VNC or remote into a bunch of machines one by one. It's just not going to scale. If they all start at the same time, that's when an effective denial of service attack scales out.